Hey everyone, welcome back. It's been a little bit since the last video, and we're still kind of chasing an issue with the big jet, a starting issue, which I'm hoping we have resolved, but we're waiting for the weather to clear up. We've actually got quite a bit of snow the last couple of days, so waiting for the weather to clear up so we can go out, do another test run, and share some more content on that. I do want to introduce the car, I do want to introduce that engine, go over it in detail, but I figure we'll start with the little guy. We'll start with this. This is not the first jet I had. It's not jet, I suppose. It's a gas turbine. This one I got a few years ago. It was actually in a Boeing 727 at the Fanshawe hangar just at the London airport here, just outside of where I am. And what this does is, it's called an APU, an auxiliary power unit, and what its job is, or its purpose, is to power the aircraft when it's on the ground. I think you can run it while it's in the air, but typically these are run on the ground, and what they do is they provide electrical power for the aircraft as well as air starting for the engines. So any commercial airliner you see nowadays has one of these, something similar to this somewhere in the aircraft. It's a lot more fuel efficient, and they need this little guy to start the big engines on the ground. So what I'd like to do is go over the components of it. I'm not going to be able to run it right now, but I do have video that I'm going to add later of running it a couple years ago. The stand will look a little bit, or the cart will look a little bit different than it does now, and some things will be a little bit different, but it'll show it running. In any of the videos that you see, that I've seen thus far of the car and the jet, it's using this to start it. So, well, first off, I've got a diagram here we can go over with the airflow, how it works, because we can't really see the inside of it. We'll go over how it works, and then we'll just do a walkthrough on the outside. Again, this is more of an intro. I'm not going into the details on how every single system works. It can be a little bit complicated, but at least we'll get an idea, an overview. So this is the basic configuration of the APU, the Garrett GTCP85-98C. What we have here is the air intake. The air gets sucked into here. These hash marks are the, I guess we call them impellers, compressors. So this is a double-sided centrifugal compressor. This is the second stage compressor, and this is the turbine. So the air comes in here, follow the arrow through a series of ductwork. It goes through this part. Remember, think of it as a circle, right? We've got the air comes in through here, comes in here all around it. Same on the other side, it comes in the other side. So if you picture like a turbocharger wheel, imagine it has two sides. It's sucking in air from both sides. So sucking in here and here, through a duct to the second stage compressor wheel, up here into the combustion chamber, combustor liner, outer case. This is where ignition happens, air, fuel, spark happens. Of course, once it's running, it doesn't need spark anymore, it's self-sustaining. The hot exhaust directs through here, through the turbine wheel, and out the back. Very simple. Let's have a look in the back of the APU to see what that wheel looks like. Well, these thermocouples are in the way, I can't really get in very well, but these blades continue all the way to the back. They're one piece. So the exhaust comes out and it drives this wheel, which helps sustain RPM and run the compressor up front. Okay, now that we have a basic idea of how this thing works, let's see what's on the outside to help make that happen. So we'll start here right at the intake. This is the intake screen. This keeps all FOD or rags and anything you don't want to get sucked through the engine. It keeps the big stuff out. Let's see if we can see in here with the light. So you can see the duct. I guess I could have taken the screen off for you, but this is a duct. That's a duct. It is kind of dirty in there, but here's one side of the impeller, and the other side is buried up on this side. So air comes in either side, goes through these ducts into the second stage, which is right back there, just out of sight. this is where all the air comes in. Then it goes through the center here. This is the combustion chamber. This is where all the fire happens in here. This is a fuel nozzle in here, so it takes high pressure fuel, dumps it into the combustion chamber. This is your igniter. This is what sparks to light it off for the first time. Here's your igniter box. This is the box that takes 24 or 28 volt DC, does magic, and ignites in here. This here is an oil cooler. So we have, let me get out of the way. We have our main accessory drive. Let's go to the other side actually. We have our main accessory drive right here. So the engine spins a shaft and then in turn spins all of these different gear pads, I suppose, at different speeds depending on what's required. This runs a fan that actually cools, sucks in air through here and then blows it out through here. So oil is running here as well, and that cooling air cools the oil. This used to have a duct that went to here. This used to be an AC, 115 volt AC 3-phase 400 hertz generator for the aircraft. Don't need it anymore, so I replaced it with this 28 volt DC 570 amp generator. And we use this to start the main engine in place of batteries. This just keeps a better consistent voltage. Don't have to worry about voltage drop and things like that. This was actually taken off of an MRAP, an armored vehicle that obviously wasn't used anymore. And yeah, it works great for this application. We had this little adapter plate machined to fit and to adapt it, and it works great. It actually still has the pulley on the inside you can't see, but in the vehicle it used to have, it ran off a belt drive. So that pulley is still in there, so if we ever wanted to convert this to run off like a gas engine or something else, we can always do that. Coming around this side, this is how you start the main engine of your Boeing 727. So it's a 4-inch hole and it runs compressed air. It takes compressed air out of the combustion chamber. Sorry, it takes compressed air post compressor section before it gets into the combustion chamber. So it's hot air, but it's not, you know, hot. And it comes out about 40 psi. 4-inch at 40 psi, do the math, that's a lot of air. And that's used to start the main engines. These are just sort of any excess oil vapor ends up coming through here and burned. What else we have around here? This is our, now we're getting into some of the controls in here. This is our fuel filter, our engine fuel filter. If we start with the tank, this tank is so big because it was also used to run the small jet. But now it's got its own fuel supply, so this will actually extend the legs of the APU, which is nice, 30-gallon tank. So anyways, it doesn't need a pump, it doesn't have a pump. It goes through this primer bulb into this water filter separator, up into the filter here, fuel filter, and then it carries on to the fuel pump. So the pump and the governor appear to be all about the same piece. Here's our solenoid, our fuel solenoid, and this runs off, this brown hose runs off straight to the fuel nozzle. I've teed into it for mechanical gauges. We'll get to this later, but here's our fuel pressure gauge. We also have our tach generator, which is what gives us our RPM signal. We have an oil filter. We have an oil pressure switch. We have, I think, here's a solenoid. I don't know if it's for air or oil. I can't remember offhand. We've got our starter right here. It's not a starter generator, it's a starter. We have a multi-function switch buried in the bowels of this thing that, depending on the RPM, it throws weights, either overspeed, tells certain components to drop off as far as starting goes. It just makes the starting sequence automated. I built this control panel, rewired it down here, built the control panel, which we can go into now. This is more than actually what you get in the aircraft. So control of this APU in the cockpit of the aircraft, I think, has an on switch, a fire control switch. I don't even think it has a gauge, if I'm honest here. Somebody can chime in and correct me there. But what I've got is my battery voltage. So it's just going to take normal battery voltage that I've got here, except once the generator goes on, this will jump up to about 28 volts. We've got high pressure fuel, so this is what's coming on secondary side of the high pressure pump. RPM gauge, it does not read 0, therefore when it's running at full speed it goes a little bit above 100. I know that, it's okay, we can live with that. The glare of these lights, I'm sorry. Here we go. Oil pressure, so oil pressure when it's running are about 90 psi, 90 to 100 psi. Bleed air, this is the pressure that's coming out of the far side 4-inch nozzle that I'd mentioned. And of course our EGT, our exhaust gas temperature. So we do not want to exceed 681 degrees Celsius per the manual. So as a reminder, it's written up there. Here we have our master on. Make sure a key is on. So master on. Okay, so we've got battery volts. Low oil pressure. Obviously we've got low oil pressure light because, you know, the engine's not running. Now what we want to do to start it, we go to run. What that does is it basically arms the relay to start it. If we didn't want it to run, we could leave this off and hit the crank. So sometimes what we'll do, if it sits for a while and I want to build some oil pressure without running fuel through it, we'll just bump that, hold it a little bit longer, and that's a momentary just to run the starter. So if we want to run it for real, hit the run, momentary start on, and it'll start its sequence. It is automated completely. I've decided to interrupt the fuel circuit with this here so I can physically monitor and make sure that, hey, we're building oil pressure before I introduce fuel. What you'll often hear if we're watching this spin up is as soon as this gauge or this needle moves, you're going to hear the igniter start clicking. So that means that that multi-function switch is operating correctly, which is great. So then once it's running, this will spin up to 100% RPM. This is designed to run at 100% RPM. It's a generator. That's what it is. So once it gets to 100% RPM, we can hit our DC generator on, and what that does is it energizes the field of this guy, which means that this is now producing its full 28 volt DC, and we can crank out up to 570 amps out of it. This engine is, I'll get to the power ratings and specs of this. I have a cheat sheet for you, or for me to go over with you, and we'll go over some of that. Then when it's running, and to shut it off, off, and that kills fuel. And very similar to a diesel, kill fuel, it's done. This load air is just a switch for opening up that valve at the other side. If we ever needed if we ever had an engine that needed an air start, this would be perfect. This will start it. Smoke, I had momentary switch here. I had rigged up a little pump injecting fuel into the back of this thing, and I do have a video of that. I'll show it here. So just playing it with some smoke, and it works pretty good. I think we'll likely do that with the big jet. And then of course our momentary crank just to spin the engine over. Oh yes, I have specs now. Here we go. Alrighty, I have some specs on this engine here. Add dry weight, almost 300 pounds. Not too bad, considering the power it puts out. So it's rated, its horsepower rating, there's different configurations. So if it's not bleeding air out for engine starting, the output shaft for the generator, which I think is a 40 kVA, 115 volt, 400 hertz three-phase generator, if it's not doing that, the shaft is rated at 100 horsepower. So this little shaft over here is rated at 100 horsepower. If your combined pneumatic power output with the generator running, it's about 50 horsepower. So actually, oftentimes, whenever you're flying commercial and you're sitting outside, not sitting outside, when you're flying commercial and they go to do the engine starts, the lights will go out. At least on some of the older aircraft anyways. And that's because they need that power. They've got to lighten the load in one spot to get maximum power on the other spot. So that's why you'll see some of the lights go out. Let me know if I'm wrong on that, but it makes sense to me. Maximum speed is about 44,000 RPM. Nominal speed on the turbine rotor, or I guess the whole rotor assembly, is about 42,000 RPM. So that's cooking. That's all the specs on that. What am I missing here? Let's go see what I'm missing. So we've got our dual battery set up here for 24 volts nominal DC. This is our oil reservoir. That's the one. Words. Obviously, we take this out when we go to start. Always safety first, right? These are the leads that come off the generator to a cam lock system that we have at the opposite end of these in the car. It's for starting. The cart, you'll see the base chassis in this video of it running previously, but it's sitting on an old lawnmower chassis. Rigged it up. I can tow this and it turns the wheels. Works pretty good, better than pushing it, I'll tell you that. I found that the wheels at Caster on their own, they ended up folding over and they were just terrible. So I like this system much more. This is here just to keep our heat shield off the tank. It's very temporary, although we all know how long temporary things last. So as promised, since it's pretty much a snow squall and blizzard out there right now, we're not going to take this out and run it, but here's a video from, I want to say 2 years ago, of this thing running. This was actually the second time I ever fired this thing. So the second time I ever ran fuel with the starter to get it going. Here's a video of that going. I'll tell you right now, headphone users, beware. She's loud. Okay, here we go. Well, I hope that was somewhat informative, help you understand how these little guys work, how common they are, and what we're using it for. The next few videos will likely be a similar introduction and overview of the PZL SO3 turbojet. It's a copy of the Rolls-Royce Viper 8, which is the little engine that's little bigger than this, but relatively small for turbojet, mounted in the back of the Pontiac G8. So I want to go over the SO3. I want to go over the G8 with you because it has its completely own set of systems to make the jet operate. So with that, until next time, thanks for watching.